You'd like to see my face, right? Right. Wait a second. Okay. Come on. My slides. Oh, okay. Okay. So I'll try to talk about the holoproencephaly and its spectrum. Most probably, you know about the midbrain abnormality, like a holoproencephaly to the genesis of the corpus callosum, right? But I would like to focus on today the embryology and obvious types of the HPE, holoproencephaly, and spectrum. Now, first of all, the prosencephalic development. The prosencephalic development means the process of the prosencephalic development. The one prosencephalon is going to be the two brains, two hemispheres. Let me see. Okay, the two brains called the telencephalon. And then this is a normal 8 weeks. The already 8 weeks. You can see in the 2D or 3D ultrasound. Or here you can see this is a very old picture at 2014, 10 years back. But you can see the two brains, by ultrasound. So it is very easy to see the two brains in the as early as 8 weeks of gestation. Now, holoproencephaly is a brain condition in which the two hemispheres of the fetal brain do not fully separate. Okay, and as you know, this is a schematic illustration of the lobar, semilobar, and allobar holoproencephaly. And in image, the typical actual images of the normal brain and allobar, semilobar, and lobar, and the variant of the holoproencephaly. And the prevalence and the incidence is like this. The prevalence of the live-born children is 1 out of 10 or 16,000. However, incidence may be as high as 1 out of 250 in first trimester. Why? Because most of them died during the pregnancy. Now, the clinical symptoms are like, the developmental delay, seizures, epilepsy, and etc., etc. And they have many kinds of the facial abnormalities. And now, the choroid plexus is a key. The choroid plexus derived at 8 weeks of gestation. And then, here you can see that this is the 8 weeks, 9 weeks, and 10 weeks of gestational age. And you can see the choroid plexus in each hemispheres, right and left hemispheres. However, here you can see this is the 11 weeks of gestation. If you look at this, the choroid plexus is continuing from left to right. And also in the mid-sarser section, you never observe the choroid plexus. However, in the case of the holoproencephaly, you may see the choroid plexus in the mid-sarser section. Here you can see this is the 13 weeks of gestation, as the same is true. So the genetic background, the causal factors of the holoproencephaly is the chromosomal abnormality like trisomy 13, 18, and triploidy, and etc. And gene variants, sonic hedgehog, SHH, and any other, the ZIG2 and others, and certain genetic syndromes shown here. And also, that it's teratogenic agents, including the maternal diabetes, are one of the causal factors of HBE. Now, this is the phenotype-genotype correlations of the holoproencephaly, and also, that this figure shows that how those genes are related and created the development of the malformations of the proencephaly. Now, this is the very interesting experimental study by the Japanese colleague, and this is a wild type, and this is a normal, and this is a knockout mouse of the sonic hedgehog, and you can see this is the holoproencephaly. And now, before 11 weeks of gestation, as I told you, in the first trimester, you can detect, the 1 out of 250 cases, the holoproencephaly very, very often. So this is 9 weeks and 6 days, and you can see here the continuous choroid plexus. Here also, that you can see here, and this is a trisomy 18. And this is 9 weeks and 4 days. Also, you can see the choroid plexus here, the continued from the left to right, and this is also trisomy 18, and this is a trisomy 13 case at 10 weeks of gestation. And here, this is 9 weeks. It looks normal baby. However, this is very small baby. The 8 weeks and 3 days. There is a minus 3.4 standard deviation. And here, this is a very small baby of the CRL 19 millimeter, but how different from the normal? Here you can see in the normal case, in this stage, already 2 brains. However, this case, 1 brain. This is the very early stage of the holoproencephaly, and this is a triple D, 69 XXX. And this baby also 10 weeks of gestation, minus 3.7 standard deviation, and then this case also the very early stage of the holoproencephaly, and also that is a triple D. And between 11 and 14 weeks of gestation, this is 11 weeks of gestation, you can see again the looking at the choroid plexus, and also you can see the polydactyly, and this is the trisomy 13, and this, you can see the very, often see the polydactyly, and this is the 12 weeks of gestation, the very similar, with the cleft lip. And this is a trisomy 18 case, that this is very abnormal case, it looks, at a glance, it looks like, the other abnormality, but this is a trisomy 18.
Mm-hmm.
You can see the very clear abnormality of the brain. And this is 14 weeks, another case, trisomy 18. And this is very, very rare case, the monosomy 21 mosaicism. And this is very abnormal and very rare case of the holoproencephaly related to the chromosome 21. And mid-gestation, here you can see this is not mid-gestation, this is 13 weeks, and nuclear translucency increased, and it looks normal, right? And here you can see the midline here. However, 19 weeks of gestation in this case, this is a trisomy 18. This is a lobar holoproencephaly, and if you can see that this is not actually the corpus callosum exactly, and also the face looks normal, but if you look at this, there is the not normal appearance of the face. And the other genetic factors, the first time I'd like to see the case, 13 weeks of gestation, you can see the proboscis and the holoproencephaly, and then here you can see this is the polydactyly, and if you shake this baby, you can see here the polydactyly, out of the fifth finger, and then maybe that you can see that this might be the trisomy 13, right? However, the qPCR was negative. So the question, what is suspected in this case? 22q deletion, 1p36, 21 hydroxylase deficiency, 7q36, or credit chart, 5p minus. Which one? 1, 2, 3, 4, 5. 1, 2, 2, 3, 4, 5. Oh my gosh, everybody's sleepy. The answer is 4. So only one, who is, stand up. Stand up. And of course, she's the mother of genetics, right? Okay, so why this 7q36 deletion is the answer? Because this is the case of the 2p partial duplication and 7q partial deletion, and there is a unbalanced translocation, and here you can see 7q36 includes the sonic hedgehog, and MNX1, this is the motor neuron, and the pancreas homeobox 1 is the protein coding genes. So now the other case, 13 weeks and 4 days, and most probably you can notice that that this is a very abnormal limb, upper limb, right? And also you can see the cleft lip, the bilateral cleft lip, and then this might be something. But qPCR 21, 18, 13 was negative, but this one is Cornelia de Lange syndrome, 1 in IPDL gene variant. Okay, so sometimes if you have no trisomy 13, no trisomy 18, think about that. You have to dig deeper to see the genetics. And angiostructure, usually, this is the normal medullary veins. Here you can see the medullary veins and the normal reticular striatum of the arteries, at 20 weeks of gestation. Now, this is the 20 weeks of gestation holoproencephaly. Everybody knows, but this is a holoproencephaly. Maybe that you are confident. And then here you can see angiogenetics. Angiogenesis is a quite normal appearance. Now, the facial abnormality, many kinds of the facial abnormality like this, the many of the textbooks show that, that this kind of the very odd faces, with the holoproencephaly. And here you can see, this is the proboscis with a lobar, and this is also the proboscis. And here, this is I'm not quite sure that this can be called proboscis, but this is also a lobar holoproencephaly. And if you look at this, that this is the eye lenses, right? The eye lenses. The eye opening is only one, however, inside 2 lenses there. So this case also you can see the 2 lenses, but 1 opening of the eye. And sometimes, that you can see the exophthalmos. Don't laugh. This is a reality. That this is the case of the holoproencephaly, and this is also the holoproencephaly exophthalmos, and here also. And sometimes, the opposite, microphthalmia is seen in the case of the holoproencephaly, and sometimes cataract in the case of holoproencephaly. Now, here you can see the normal, the hyaroid artery is like this. Here you can see those are lenses, and here you can see this is a normal hyaroid artery. However, holoproencephaly 13, which the trisomy 13, and here you can see this is the malposition of the hyaroid artery. Now, the fetal scan, this is a normal scan at 19 weeks of gestation, and this is the normal lip, right? And however, here you can see, this is the bilateral cleft lip. The usually, trisomy 13 or holoproencephaly is associated with bilateral cleft lip, alveolus, and palate, and like this. And also, this is a SMMCI, solitary median maxillary central incisor. And here you can see only one teeth. You know that? This is very much associated with holoproencephaly. And this is a normal alveolar, right? And here, this is the article, and this is the tooth bud. And here, this is the only one here. Not this, the indentation here in the middle. So this is the solitary central incisor. So the fingers and toes, and sometimes you can see the polydactyly in the trisomy 13 here. The post axial polydactyly is seen with okay, I understand. So the maybe we can see the very unique variant of the holoproencephaly, and here this is the ultrasound, and this is the MRI, and we published this this case, and the very unique abnormal the case of the holoproencephaly. This is one of the spectrum. And also, the Zepto pre-optic holoproencephaly is recently introduced, and this is, sometimes about the zepto-optic dysplasia. However, zepto-optic dysplasia is more focused on the neuroendocrine features, and however, zepto pre-optic holoproencephaly is a part of the holoproencephaly spectrum. So, okay, so I think the last part is very speedy. So I'm not quite sure that you can understand, but I hope that that this is the holoproencephaly from the obvious forms to the HPE spectrum. Thank you very much.